Hey guys, welcome to Unit 11, Lesson 5. We are going to be doing more related rates problems. So pause the video and try the warm-up. The warm-up says the radius of a circle is increasing at a constant rate of 0.4 meters per second. So this is the circle and it's the rate of change. So I'm going to say dr dt is what? 0.4. It's increasing, so it's going to be positive. Right? Again, if you were in doubt over here, the units tell you a lot about what is being given to you. Meters per second. So per second is the rate, and since it's meters, so it has to be dr dt. It's asking us what is the rate of increase in the area. So I want to find the rate of change of area, so which is dA. We're using uppercase A for area. dA dt I do not know. Of the circle at the instant when the circumference is 60 pi. So your circumference is 60 pi. You need to know your circumference formula, because if I write my area formula, because I want to find dA dt, so my area is what? Area of a circle is pi r square. I need my r. I don't know my r, but I know my circumference. I also know my circumference formula is 2 pi r is equal to 60 pi. If I solve for r, I'm going to divide by 2 pi on both sides. I get r is equal to what? 30. So I know my r is 30. I know my dr dt, so can I not find my dA dt? So all matter is of first taking the derivative and then substituting it. So my derivative on the left would be dA dt. We are differentiating with respect to time. So this would be, remember, pi is just a number. So use your power rules. It's 2 pi r and use implicit differentiation dr dt. Right? Now all I'm going to do is substitute in dA dt is equal to 2 pi, what's my r? 30, and it's 0.4. And if you put that in the calculator, this would be, or we're not using the calculator actually, sorry. So your answer will be in terms of pi, because it didn't tell us to round, right? Which would be 24 pi. It's area, so it's going to be meters square per second. Okay, so now multi-formula problems. Sometimes to solve a related rates problem, we need to use more than one formula. So that's what you're going to be doing here. And again, go by what's given. Always, if you want to draw a picture, that's great. And go by what is given, look for what is to be found, and then take it from there. A beach ball is deflating at a constant rate of 10 cubic centimeters per second. So again, it's deflating means what? The volume, because again, look at your units. Cubic centimeters, that are the units for volume. Per second means its rate. So dV dt is what? And it's deflating, so it's going to be negative 10 centimeter cube per second. Now it's saying the volume. I just know volume is 256 over 3 pi cubic centimeters. Again, look at the units. When in doubt, the units throw away a lot of information. What is the rate of change of the surface area? So I want to find my rate of change of surface area. So let's use S for surface area. So I want to find ds dt, right? Now look at that. Look at your surface area formula. It's 4 pi r squared. I need to know my r. I don't know my r, right? And also I need to, when I differentiate, I need to know my dr dt. So I don't know that, but how can I find my r? I know my volume. And look, if I set my volume here, substitute volume for this value, can I not find r? So the first step is to find r. Then we're going to use that to find dr dt. And then once we have dr dt, we are going to substitute into the surface area formula, and we're going to find the rate of change of surface area. Does that make sense? So let's start with that. So it's going to be 256 over 3 pi equals 4 over 3 pi r cubed. Okay, so now if you cross multiply, the pi is actually, I'm going to change colors. pi's actually cancel out, right? So if you cross multiply, the 3's also cancel out, and 256 divided by 4 is what? 64. So r cube is equal to 64. You just cross multiplied. And then cube root, right? So cube root of 64 is 4. 4 times 4 times 4, or 4 to the third power, is 64. So r is 4. So I found my r. That was my first thing. Now, because remember, I know my r, but when I take my derivative, I need to know my dr dt. So second step I can do is take my volume formula, find the derivative of it, and from there it can help me find dr dt, because I do know dv dt. So my volume formula is 4/3 pi r cube. So take the derivative with respect to time, so it's dv over dt equals, the 3's cancel out, it's 4 pi r dr dt. I don't need the parentheses actually, right? So dr dt. Now I'm going to just, it's 4 pi r squared dr dt. Now I'm just going to substitute in, I'm going to zoom in actually. So my dv dt is what? -10 over, no, it's just -10, equals 4 pi, what's my radius? I found it to be 4 square, so I'm just going to substitute, and I don't know my dr dt. So do you see, I just had one variable here to solve for. So I am going to simplify this. I will get 64 pi here, so it's -10 over 64 pi equals dr dt, which would be same thing as what? -5 over 32 pi. So dr dt is -5 over 32 pi. Now this is step 3. That's our actual question. What it's asking us to find the surface area. So S is equal to 4 pi r square. I'm going to take the derivative. So it's ds dt equals 8 pi r dr dt. Right? So then what do I get? All I'm going to do is substitute in. I need to find ds dt. 8 pi r is 4. And dr dt is what? -5 over 32 pi. The pi's cancel out, and 8 times 4 is 32, and the 32 cancel out. So I'm left with my rate of change of the surface area is -5, and the units would be centimeter squares per second, because it's area. Again, it did not ask you for the units, so if you're not sure, don't write it. But if you write it and they're wrong, then you lose points. So I just want to highlight that. Okay, let's do another question. Example 2. So here again, it's giving it's actually broken down into parts. So let's do that. A radius r of a sphere is increasing at a constant rate of 0.04 centimeters per second. So my rate, that's my rate. So dr dt is 0.04 centimeters per second. At what time? At the time when the radius of the sphere is 10, so my radius, when radius is 10, what is the rate in increase of the volume? So that's a pretty straightforward question, right? I want to find dv dt. So we're going to use the volume formula. You have to remember these formulas, guys. Sometimes they're given to you, but sometimes they're not, so we can't count on them. So let's start memorizing them. So it's 4/3 pi r cube. Take your derivative. This would be 4 pi r square dr dt, right? Substitute in 4 pi, my radius is what? 10 square times 0.04, right? If I simplify that, it would be just dv dt is 16 pi. And this is what? My volume, rate of change of volume, so centimeter cube per second. Okay, now it's asking part B is at the time when the volume of the sphere is, so the volume is 36 pi, right? What is the rate of increase in the area of cross-section through the center of the sphere? Okay, what is a cross-section? First of all, cross-section is literally a slice. So if you cut the sphere, what shape would you see? Wouldn't you see a circle there too? So it's asking me what would, so that's a circle. So I basically want to find dA dt. That's what I'm looking for, right? Rate of increase of the area of the cross-section. So since the cross-section is a circle, so I'm going to find that. So I just know my volume. I don't know my R. In order to use my area, let's write down our formula for area of a circle. It's pi r square. I do not know my R, neither do I know my dr dt. Actually, dr dt is from the top. The question is giving us 0.04 centimeters per second. So it is there. So I'm going to write that. So dr dt is given to us. It's 0.04, but I do not know my R. So can I not use my volume, which is 36 pi, and find 4 by 3 pi r cubed? Right, the pi's cancel out. When I cross multiply, I get what? 27 equals r cubed. So r is what? 3. So I got r equals 3. Now I'm going to take the derivative here. It's dA over dt. It's basically 1 times d over dt. Do we all understand that? Right? So 2 pi r dr dt. So now all you're doing is substituting in dA over dt equals 2 pi. What's my radius? I just found my radius to be 3, and my dr dt from above the question was given to us. So this would be actually 2 times 3 is 6. 6 times 0.04. I can either actually, I'm going to just change it into a fraction, which would be 6 over 25 pi centimeter. Again, it's area square per second. Part C. At the time when the volume and the radius of the sphere are increasing at the same numerical rate, what is the radius? So it's saying at the time the volume and the radius of the sphere are increasing at the same rate. Meaning what? My dV dt is same thing as dr dt, right? So I want to find the radius. So I'm going to write my volume formula, which is 4 over 3 pi r cubed, which take the derivative. It's dV dt equals 4 pi r square dr dt. So what can I do? Can I not substitute dr dt with dV dt? Or if I forget that, right? So these will actually cancel out, and I'll be left with just 1 equals 4 pi r square. So r square would be what? 1 over 4 pi. Take the square root. Radius is positive, so it'll be 1 over 2 rad pi. And that's your radius. Okay? If you have any questions, please reach out to me. Finish out the remaining questions, and good luck, guys.